In this problem, we're asked to calculate the free energy for the following reaction at 200 degrees Celsius. Now, my table of thermodynamic values is for 25 degrees Celsius, which is pretty typical. If we were at 25 degrees Celsius, I could calculate the free energy by just doing the free energy of the products minus the free energy of the reactants. However, because the free energy depends on temperature, I can't do that. However, the enthalpy and entropy don't depend very much on temperature. So I can use the tabulated values of the enthalpy and the entropy, and then I can use that delta G is equal to delta H minus T delta S. Alright, so the first thing we want to do is calculate the free energy, calculate the enthalpy and the entropy for my reaction. So to do that, I'm going to do the enthalpy of the products minus the enthalpy of the reactants. So the delta H of reaction is the products minus the reactants. Now if you notice, my first product is manganese, and I didn't put any values for manganese in the table. That's because we know that the standard enthalpy of formation and the standard free energy of formation of an element in its standard state is 0. So the enthalpy for manganese is just 0. I've got 2 carbon dioxides, so I have to use my stoichiometric coefficients. So I've got 2 times negative 393.5, and I subtract from that the enthalpy of the reactants. Alright, so this simplifies down to negative 787, and then it's minus a negative 741. So these problems, one of the tricky things can be keeping the sign straight. So I've got a negative times a negative means a positive, so I've got negative 787 plus 741, and the enthalpy for my reaction is negative 46 kilojoules. All right, now I'm going to do the same thing for the entropy. And so that's going to be 32 for the manganese, 2 carbon dioxides again, so the enthalpy comes out to be 11.1 joules per Kelvin. So now that I have the enthalpy of reaction and I have the entropy of reaction, I can calculate the free energy, and we'll do that on the next slide. Alright, so I've put the enthalpy and entropy that we calculated on the previous slide, and to calculate the free energy we're going to use that delta G is equal to delta H minus T delta S. Now we have to be a little bit careful about units. So the temperature unit needs to be in Kelvin. I'm given the temperature in degrees Celsius, so I need to convert that into Kelvin. So the temperature is 200 plus 273, or 473 Kelvin. The other units that I need to be careful of are for the entropy. So if you notice, the enthalpy is in kilojoules, the entropy is in joules per Kelvin, so I need to be working in the same units. Because we typically report free energies in kilojoules, I'm going to convert delta S from joules per Kelvin into kilojoules per Kelvin. So to go from joules to kilojoules, I just need to divide by 1,000. So the entropy is 0.0111 kilojoules per Kelvin. So now I'm ready to go ahead and plug in my values into the equation for the free energy. So I've got negative 46 kilojoules for for the enthalpy, minus 473 Kelvin times 0.0111 kilojoules per Kelvin. So the kelvins will cancel out. I'll be left with kilojoules for that answer. And the free energy comes out to be negative 51.2 kilojoules. And that is our answer.